This video is made for the Project 3, replacing an existing structure on Earth with an optimal design to be constructed on Mars using Virtual 3D. In this project, a team of 5 is formed to conduct the optimization of the dome-like structure on Earth and eventually fulfill the demand for Mars colony. The design detail will be introduced shortly. Optimization design for the existing structure on Earth. The drawing is based on the site of Northland Shopping Central Dome on Earth. The design identifies one finite elements model to check the innovative designs. Reasonable assumptions are used in the model. There are two parts that are designed separately and assembled before the job is submitted in the abacus. The first part is called dome and connection, and the other part is called RS connection. The screenshot is shown below. The design plans to use 3D construction printing to build the projects. The material is called volcanic rock basalts that are similar to concrete and available locally from Mars. The load design for the case is based on the student number of our group. The load distribution is shown in the figure. Once the FEM finished modeling, the design used BSO2D to perform the optimization for the RS connection. A similar model is identical properties is built in the software. The screenshot is used in Abacus to generate the optimized FEM. This part is for the optimization design on the dome-like structure. Once the modeling on Abacus is done, rendering it on the Mars, the final image is shown below. Its optimal topology is used to create a 3D model for 3D construction printing from the results of Abacus.
For the size of printing nodes, which use 0.2 meters for 3D printing and 2 printing direction are also considered in this design. To achieve the maximum structural efficiency, the local geometry is optimized in terms of reduced max tensile stress at the expense of max compressive stress with a comparison of stress levels. This process is called material anisotropy. For the location where inclination can be changed, most parts control within 30 degrees, which means it can save to use a lot of supporting materials. For the other details are shown in the figures below. Due to the weakness of concrete-like materials, 3D printed structures will deform under the action of gravity during the curing of materials. The final shape of the structure will be different from the design model for 3D printing. Sets are to use Abacus to form a new part of the deformation topology from the ODB file to check the optimal design sensitivity, the difference between the distortion topology and the original topology, which is shown in the figures above.
This part is for verification and validation of our structure, and this part will be conducted from the following steps. First is error or warning information and rebalance for equivalent following inspection and mesh convergence check. And from a report, there's details information for those steps and to verification and validation of our structure.
In 3D optimal design using mesh mix part, I use the analysis function on mesh mixer to find out the supporting structure of optimal design. Also check the feasibility of model created in 3D printer. Next, to reduce the tensile stress of the optimal design, I use fillet and spline function in Abacus.
In this project, the structural strength is fulfilled for the gravity demand on Mars. Thanks to the optimization procedures, the efficiency and the material usage are improved. However, some errors such as software version differences occurred, which caused some functions disabled. This can be solved by modeling in the same CAE environment. Thanks for watching.